please state your name and affiliation.
Okay, I'm Claudia Scarlata from University of Minnesota.
Please talk about your background, how you are interested in what you're researching.
Okay, so my background is in physics and astrophysics, and how did I become interested in, I always loved physics, and that's how I went in to study the stars. You don't really want to know the real answer, that's the point. You will cut this.
That's okay. What are you researching in relation to the exhibit?
So, in relation to the exhibit, we are studying how galaxies form their stars. And specifically, we discovered very recently that there is a transition in how galaxies form their star early on in the universe and how they form stars today. So the idea is to understand what is causing this transition. Specifically, right now, today in the universe, galaxies form stars very smoothly, very quietly, if you want, while back then, a few giga-years ago, a few billion years ago, galaxies were way more active. They were booming with star formation, and they were also forming stars in very large clumps. We call them clumps. And so to understand what happens in these billion years, it's the role of the research project that is presented in the exhibit.
What is the name of your research project?
UV-UDF would be the head of the project, is the ultraviolet side of the Hubble Ultra Deep Field, which is the deepest field that has ever been observed with the Hubble Space Telescope. It's a tiny little patch of the sky.
What are some of the recent cool discoveries?
In UV-UDF in general, or in citizen scientists?
In, I think probably the better order is to talk about what are the discoveries from your research, and then we'll talk about how it relates to citizen science. So it's kind of.
Well, from UV-UDF, I do a large. I mean, my research is not only focusing on this, but UV-UDF has been one of the greatest. UDF in general has been one of the greatest fields to study the most distant galaxies in the universe, the very, very, very first ones that formed a few million years after the Big Bang. So that's probably the greatest discoveries that that particular field has produced, and I'm part of some of those projects. Going to the more distant universe, then it's what I just mentioned, this new mode of forming stars in galaxies. The evolution of these star-forming clumps has been one of the greater discoveries of the past few years.
And how do citizen scientists and projects such as the universe help with your research?
They do a great deal of work. So the idea is that when you have a galaxy, you have to identify where the star-forming clumps are. And that's something that you can write an automatic software to do for you, but that's never going to find the smallest clump, the most difficult one, and so on. There is the need to have help, visual inspection, first of all, and help from someone to really find all the star-forming clumps. So that's what the citizen scientists do for us. They look at the galaxies, they tell us what shape they are, whether they are nice and smooth, or if they are irregulars, and so on, and count the clumps, the star-forming clumps that there are in these objects.
What makes the citizen involvement so important?
What I just said. It's crucial. I mean, and it's becoming more and more important because surveys are becoming larger and larger, so it's needed.
What are some of the cool discoveries of these citizen scientists?
One of that I really like is, there are many. My favorite is probably the discovery of the green peas. These are very tiny galaxies. They have called them the green peas because they look like green, like literally green peas. And they look like that because they have a particular emission line spectrum for some specific properties they have. But the reason they are so cool, it's because these objects are nearby, in the nearby universe, but they're probably the best analog we have for the objects in the very early universe. They're very small, very young, they're not metal enriched and so on. And so if we want to study the very high redshift galaxies, we can study these objects because they are very similar to those galaxies that are in the early universe.
Do you think these objects, these green peas, would have been found if not for the Zooniverse?
Maybe eventually, but nobody was looking for these objects. So it was, yeah, no, that was a discovery that it's certainly owned by the Galaxy Zoo project.
This has sort of been answered in previous questions, but it's okay if you are restating some of the things. Why is this research important?
This research is important because the end goal is to understand how we go from a smooth gas distribution to the galaxies we have today. We need to study their evolution, their formation and their evolution. And so one aspect of that is to understand how the stars form and how the process of star formation changes over time. So the research we are doing will shed light on that aspect specifically through the UV light.
What are some of the next questions we need to explore?
Well, one of the next questions I will be focusing on with my students here at UMN is to try and automatize the problem of galaxy classification. But to do that, we will always need the input of the Galaxy Zoo project, of the citizen scientists. And the reason for that is the next generation of surveys like the LSST and so on, large telescope that will survey the entire sky over and over again, will produce billions of galaxies. So those numbers will be impossible even for the citizen scientists. So we are going to come up with a scheme that incorporates both citizen scientists and automatic algorithm to be able to classify the entire surveys at once, basically. It's going to be a loop, citizen scientist, automatic classification, and so on.
That is our last question. I don't think of anything to expand on, or is there anything you would like to talk about more than that?
Well,